Yeah, let's get into it. So before we learn about serverless, I think it's very nice to talk about server. So what is a server, right? A server is a computer or software system that provides specific service, resources, or functionality to other computers known as clients. Right? So a server is like a computer system. And what this means is that basically a server is a computer. So if you have a local machine, by that I mean your computer, your laptop, you could actually turn that to a server and provide resources to other other devices, right? You could get some resource, send it or share with other devices, and your system is like a server that is distributing resource to other devices. Now, what is serverless computing? Serverless computing, often referred to as serverless, is a cloud computing model in which cloud providers automatically manage the infrastructure. So here you're actually allowing providers like AWS, you're allowing providers like Google or probably Microsoft to manage this, computing automatically for you, right? And these infrastructures, you're allowing these providers manage this for you. And what that allows you to do is that now they handle auto scaling for you and a lot of other things. So see, said automatically manage the infrastructure required to run and scale applications, allowing developers to focus solely on writing code. So you're not bothered with how do I set up this server? How do I manipulate images, right? How do I compress images? And how do I efficiently store or save this image or something like that? You could just push an image to S3 and you have a Lambda function or something like that that is managing this for you and doing all the magic for you, or probably a Lambda function that is like, let me say, pulling from that base of that event and setting up the spinning up the server, and all you have to do is just write your code. How do I want to do this? I want to present it to a front end or expose it to something or something of that nature, right? Now, in a serverless architecture, developers do not need to worry about provisioning, configuring, or maintaining servers or virtual machines. Instead, they can define and execute code in response to events, and the cloud providers handle the underlying infrastructure. So here, the serverless infrastructure is based off events, right? So, for instance, you make a change in some resource, and that would that's an event that has happened, right? And you have an infrastructure, an architecture infrastructure, a serverless infrastructure that needs to respond based off that event. It could be a Lambda function. It could be you want to save something to a DynamoDB, or something of that nature. Probably you update an image to an S3 and you want to get that image, get the information about that image. Of course, there are ways you could get the information about an image, like the probably something like the geolocation, the image size, and all that. You want to get all that information and store it on some database or DynamoDB. Well, that's what serverless allows you to do, right? So events, right? So serverless, we've already discussed that serverless applications are event driven. So it's like, consider it like an event driven architecture. Everything you do emits a certain event, and depending on whether you're listening to that event or not, you're kind of processing those events to the right place you want them to be, right? So meaning they execute code in response to specific events or triggers. These events could include HTTP requests, changes in data, time-based schedules, or custom events generated by the application, right? So how can we identify a serverless computing? Okay, for instance, you know, I believe this is very self-explanatory. You know, one of the cases, or one, you have to look at the characteristics of a serverless application. So from what we discussed so far, you see that a serverless application, sorry, please. Sorry about that. My
Yeah.
awesome neighbors have to uh, come around. So
Okay.
we are now talking about the characteristics of a serverless application. Well, we could have a lot of infrastructure out there, but how can we tell that this is part of a serverless system? Well, one of these characteristics you have to look at is it mostly responds to events. So serverless systems respond to certain events or triggers, right? And they are stateless, right? Serverless systems are mostly stateless, right? Like the Lambda functions are stateless, meaning they do not maintain any server specific states between execution. This makes them easily scalable, right? Remember, we say that your providers manage auto scaling, right, for you. And that is the next one, auto scaling. So serverless providers help you manage auto scaling. So that way, if you're having a ton of requests coming into your system, you don't have to worry about scaling your servers or anything. For instance, if you're using a regular Node.js to handle certain traffic, you will need to, separate certain traffic from the main thread. You have to do some processing and stuff like that. Spin up a child node or process. Do some crazy things and make sure that you're not blocking the main thread and all that. Well, in serverless systems, you don't need to bother about on any of this. Those are done for you automatically, and that saves you a huge number of time. So you don't need to start configuring systems, writing your own child process or spawning servers or whatever, or child nodes or whatever. You just have a system that works for you. All you have to do is write your regular code, like your regular JavaScript code or your regular Python code, and things are working for you the way they should. So we have serverless functions. In context to serverless computing, functions refers to units of codes that are executed in response to events. So you usually have these serverless functions where an event comes in, say, an HTTP request or something like that comes into your infrastructure, and you have units of functions responding to those. So you could have a Lambda function listening to an event that is coming from a webhook call from a payment gateway or anything of that nature. And when this comes in, you're using that to do some processing. You're sending, redirecting requests to the right server that sends that request, and all those things, right? So we have the benefits of serverless computing. So, having these, what are the benefits? What are those things I'm going to gain using a serverless infrastructure over managing my own resource, or probably going to DigitalOcean, spin up a server, and having to manage all these, right? One of them is simplified development. So it takes away the ambiguity of managing servers or robust systems where you have to spin up servers, do a lot of management and all those things. Trust me, it is very resource intensive managing servers yourself. Very resource intensive. You have to buy server spaces, you have to monitor those and make sure that you're scaling properly, you're using the right, you're using certain load balancers or whatever to redirect requests, making sure that you're not putting stress on a particular server and all those things. All those are taken away for you, right? And you have just to focus on your writing code. So you're a developer. What are you to do? Write code, and don't worry about how this works on the background. We are in charge of those. We have scalability. Serverless platforms automatically scale resources, ensuring that applications can handle traffic, right? So when there's a traffic spike, your serverless provider auto scales and scales down your traffic, making sure that traffic spikes are being handled correctly. And when there are cases where you're not using your your serverless system at all, you're not heavily being charged for what you're not using. So it's more like you're using, you're paying for what you're using, right? There's rapid deployment. So it's going to take me a lot of time spinning up digital ocean, probably spinning up a Docker container or something like that. But with serverless system, you could just plug in, a Lambda function, and in, like, let's say you've completed a build and you want to, you know, handle a webhook callback or something. All you have to do is just spin up a Lambda function, and in less than 1 day, you're good to go, right? You have your system plugged in and working for you. You're good to go to use that very service. But in an actual server, you have to, you know, provision a lot of things. You have to install certain dependencies. And when you're not doing things like containerization, you will definitely face hell in those scenarios, right? So we have reduced operational overhead, right? Cloud providers handle routine operational tasks such as patching, maintenance, and security updates. So you're very sure that your service is mostly secure because, well, there's constant update, security update for you that is done for you by these service providers or cloud service providers. Then we have easy integration. The essence of building anything is so that it can be integrated easily, and these service providers mostly make sure that it is easy to integrate their services or these serverless functions or serverless infrastructure with your regular process. So you don't have to go and start going down a learning curve, learning something totally new, just specific for that case. As long as you know how to go navigate yourself around that provider, I think you're good to go. And there are rich documentations provided by AWS and some of these other serverless providers for you that you could just look at, and you have yourself all good to go. So we, by we, I mean myself, have we've gone through talking a lot, and we now want to see, well, we've done the theory of it, but we want to see how we can achieve something with serverless. When we say serverless, some of us do not really, like, there was a time I never really understood what it is, right? And I don't know the components or how to go around that. So today, Kelechi is going to run us through, you know, building something actually. We are going to try to build something very awesome with serverless, and we are going to use AWS as a provider. So, Kelechi, over to you.
Okay, I think Melody has said a lot of what we're going to be doing today. And so, first of all, I'm just going to be projecting my screen. Let me kind of change this a bit. Okay. Okay, just hold on. Okay, so we have some of the things going here. Okay, so all right. Then just sending in my screen. Present the screen. Okay. So I think I just sent in my screen. Can you see my screen?
Yep, we can see your screen.
Okay, today I decided to use my smaller monitor so we don't start fighting with, zooming in and zooming out, something like that.
Awesome.
All right, so today we're going to be building, it's going to be a really fast build because we want to also keep the time as well. So we're going to be building a serverless application, a serverless API specifically. So it's going to be an issue ticketing application, right? We're building an API that manages issues. Let's say you're having a software product and users create issues. Like they come, and if they're having a bug, they write their issue, and somebody gets to see the issue, all right, and respond to it. So the way it's architected, or the way the number of services we're going to use and how they integrate is, first of all right, we have a couple of serverless functions like using Lambda functions, and we'll have serverless storage with DynamoDB. We also have SNS, simple notification service here. So how they all connect is, first of all, we have the API gateway sitting in front, because users gets to, let's say the app that handles users creating an issue is a front-end app that makes an API call, right? So that's handled by the API gateway. You can think of the API gateway as an orchestrator picking out handling requests from different from one API source and then forwarding that request to a given Lambda function based on the path as well as the HTTP method. Is it a post request? Is it a get request? Is it a patch request? Something like that. Okay, so here we have the API gateway. The API gateway is connected to series of Lambda function. In this diagram, we have 3 of these, and in the code we'll be working on, we'll have like I think 4 of these, or 4 of these, around 4 of these. All right. So yeah, so we have about, I think we have 5 of these. Yes. So these functions are handling get requests, create requests to create a ticket, reply requests to reply to a ticket, and all that. And these functions are connected to a DynamoDB table, right? So the DynamoDB table stores all tickets, right, for later retrieval, right? So that's what the DynamoDB table does. You can think of DynamoDB as a serverless database. Whenever you're building serverless application and you're using AWS and you're using Lambda function, the first thing you think of when you want to store data is DynamoDB. It's quite scalable based on your provision concurrency, capacity mode, and all that. Okay, so the next component here is SNS. SNS is like our notification gateway, so that one of the features of the API we're building is if request comes in, it goes to SNS, and then we can, from SNS, push that request to Slack. So nobody is sitting around looking at the database to know if a new record is, if a new ticket issue is raised, but everybody is working off Slack and listening to Slack notification and all that. So what we'll be doing is, when a new issue ticket is created, we'll send it to SNS. SNS will now fan it out to all its subscribers. And one of the subscribers we're having here is actually the Slack bot or webhook. All right. And the way we achieve that is we connect a Lambda function to SNS as a subscriber. And once SNS is triggered, SNS will fan out the new message to all its subscribers. Since one of those subscribers is the Lambda function, the Lambda function gets invoked. All right. This is what, when Melody was talking about serverless has to do with events. All right. We're listening for an event that has to do with, here we're listening for an API event, and here we're listening for a message publish event. All right. And once that event gets received, we execute our Lambda function, and then we call Slack. All right. We're using Slack webhook, and we call Slack, and Slack gets the message and then publishes it into your Slack application. So anybody, maybe the support team inside your company, could just see the message. All right, so this is what we'll be building. This is just to demonstrate how powerful serverless is. With this simple example, or with this sample example, we've been able to show several things here. All right, so we'll move on to the next part, which is the code, right? Everything we've talked about it, and everybody wants to see the code. All right, so to follow along with this, first of all, you need to ensure you have an AWS account, and also there is a starter, a branch, a GitHub branch with some starter code here that would make the process easy. So if you go on the starter branch, you'll see that we have a couple of codes here that makes the process easy. So we're going to be using the starter branch, and then we'll work our way all the way down. So what we'll be using is, we're going to be using something called serverless SAMs, right? Serverless that's AWS serverless application, what's it called, model, right? That's SAM, serverless application model. I forgot the acronym. Yeah, so SAM is like, you can think of it like a tool that makes the work easy for us. With AWS SAM, you can write a couple of functions, you can automatically manage their deployment, manage the infrastructure, because of course you need to create all these resources we just showed down here, like the API gateway, the DynamoDB, and all that. We don't want to manually go to AWS and start creating them, because deleting them and updating them might be difficult. So we want to use a tool that makes this thing simple for us. All right. And that tool is serverless application model. This is very good. Whenever you're starting with serverless, especially on AWS, you want to try something like this, like serverless application model. They also have CDK, Cloud Development Kit as well, depending on your choice. But for this, we'll be using SAMs. All right, so once you have those, ensure you have SAM installed in your computer. And here I have SAM installed because I can run SAM command. Now let me zoom in a bit. Oh, okay. I think I'm opening new tabs. Just trying to zoom in here. Okay. So I have SAM installed. I know because I can run SAM dash help, and it shows that I have SAM actively installed. All right. So the first thing we want to do next thing we want to do is we want to get the starter code. So I will go over to GitHub and I will copy the code here and I will clone it. Right. So I'll just hit clone. I'll paste it here. And I'll name it Ticket API. Right. Right. So I'm cloning that. And I'm going to go into Ticket API. And the branch, I want to go inside the starter branch. Okay, git branch. I'm now on the starter branch, so I just want to do code. Open up this in VS Code, which is a code editor. Depending on your choice, any code editor still works. Okay, so I'm just going to maximize this and I'm going to zoom in a bit. Okay, I feel this is okay.
Yeah, that was.
Okay, so first thing, we want to understand the files in this project. So number one, the first file we'll have here is the source file, which contains our source code, of course, the normal git ignore file where we state all our ignored folder and all that. Then the next important file is the make file. The make file, since I'm using SAMs and I'm also using something, I'm using TypeScript, I need to be able to bundle and convert TypeScript to JavaScript because, of course, I'm running JavaScript, right? So that's done with the make file. So the make file kind of uses TypeScript and runs some make. Make is like a build tool and run some make. And also, this project makes use of Lambda layers, because we're having several functions and these functions are making use of the same dependency. We're using Lambda layers to make the functions more optimized. So you can Google and search on what Lambda layers are, but we're using Lambda layers. So you can see we're having something called runtime dependency layers and all that. Right, so that's what the make file is doing. And the make file corresponds to the number of functions we have. Like we have the build create ticket function, we have the build Slack message Slack function, we have the reply ticket, we have the remove ticket or resolve ticket, we have the get ticket function, we have the get tickets, and get ticket function. All right, so I'm going to explain what these functions are doing in a bit, but let's walk through the files. All right, so next we're actually going to be writing TypeScript, which is also based off Node.js. So we have our package.log file, which has all our log dependencies for our package.json. Our package.json file will have all our dependencies, like the main dependencies. Since we're working with DynamoDB, we're using DynamoDB SDK. We're also working with SNS. We're using SNS SDK, and also we're using some utility libraries for DynamoDB. All right, we're also using Axios because we're calling Slack webhook. We're using actually we don't need node fetch, but this was just added just in case. We don't need node fetch. We only need Axios. We have other additional libraries here. We have UUID to generate random IDs, and also we have our dev dependencies. I think anybody working with Node.js and TypeScript, we're already familiar with package.json file. And in fact, any project I open for the first time, that's the first file I get to open, the package.json file, because it tells you more about the project and what the project is doing. All right, so we have our normal README file here. We have now another very important file we have here is the template.yaml file. You can think of it. This is actually infrastructure as code, right? Infrastructure as code, right? This is we're using code to create the necessary resources we want. This is very powerful, right? If you're the type that maybe you're looking into doing DevOps, or you want to know how to automate things, right? Infrastructure as code with something like CloudFormation, with Terraforms and other Pulumi. Those things are where you get to write code and you automatically create the resources you want. And that's what comes with SAMs. SAMs brings up these templates. Templates are where you define the resources you want, and then AWS takes that, creates a CloudFormation, something called CloudFormation stack, and uses that stack. Based on that stack and the things defined in that stack, creates the needed resources. What are the resources? What resources are we talking about here. We're talking about the these things: the API gateway, the necessary Lambda function, the DynamoDB tables, the SNS, the SNS, right? And every other things like permissions, rules needed for this application to work. All right. The good thing about it is I can run just a single command to do this, and I can run a single command to run updates, and I can also run a single command to delete it, right? So like to delete all the resources that I've worked on. So I don't have to manually click buttons to create a Lambda function or create DynamoDB tables. And also this is version controlled. So I'm going to publish this to GitHub. Anybody that makes a change to it, we are aware that somebody makes a change to it and we can revert and all that. So that's the power of SAM. That's the power of infrastructure automation, and that's the power of AWS CloudFormation.
So are you
Okay,
saying
so I'm going to,
infrastructure?
yeah.
Sorry. So are you saying infrastructure as code allows us to create a lot of AWS? Like for instance, if you are pointing to AWS, it allows us to create a lot of AWS resources like the DynamoDB and all that from just the code, like by running commands without
Yeah.
going to AWS and getting those resources.
Yeah,
Yeah,
exactly. And that is what we'll be doing today. So yeah, so standing alone, CloudFormation does that, but SAM comes with SAM template, and SAM template is based off CloudFormation, right? Which does infrastructure automation based on this template file to create the needed resources needed to run their application. All right,
oh, that's
so I'm just going to quickly run through the template file. So this is just describing what this template is doing, and we're specifying which kind of serverless templates we're using. We're using Turing 1610. These are all, most times I don't really write this. Once you do SAM init, if you're starting a new project with SAM, you run SAM init, all these things gets generated. All right. So inside here, we're specifying some global things, specifying the layers that should be used. We need a runtime layer. We're specifying some environment variables like the name, all right, referencing the tickets table, DynamoDB table, also the table name referencing the tickets table for replies. So we're storing tickets in a different table, and we're storing tickets replies. So think of it like the way our data model is we have two models. We have ticket, and we have ticket replies, right? Ticket reply, for one ticket, you have many ticket replies, right? Think of it like one-to-many relationship. For one ticket, you have many ticket replies, right? So, and those goes into two DynamoDB tables. So we're just referencing these tables as environment variables so that we can access them inside the Lambda function, right? Next, we have the
so.
yep,
Sorry. So if I'm understanding this correctly, so for instance, the same way we have, a post, we are going to have several replies on that or several comments on that. So that's what
yeah,
you're saying. So each ticket has a reply to that and all that.
yeah.
Okay.
Yeah, exactly. Exactly. And so this is just the way where how we define environment variables to be used by the Lambda function. And then we define our runtime. So we're running this function inside node 18, right? Anything from node 18. And then we're also specifying memory size, and we're also specifying timeout in milliseconds. Timeout in, I think, seconds. This should be seconds. Yeah. All right, so next we have the next section, which is resources. This is where we're actually saying, oh, create this resource on AWS, create this thing, right? So we're creating the first resource, which is a function, a serverless function. And serverless function is just another name for Lambda function, right? So we're creating the resource and we're specifying this type is a serverless function. We're passing in some metadata, which is a build method, saying we're using a make file because, of course, I showed you the make file here. And we're specifying some properties, and we're pointing, we're adding a handler here, which points to the part where we have the serverless function. All right. So if you look inside here, when we build this project will be built into a dist directory. And inside that dist directory, it mimics the same source directly, but this time it's just a dist that is we've compiled this and changed all the TypeScript into JavaScript. Right, so inside the dist, inside the handler, we have something called create ticket, and if you check inside there, we have create ticket function, right? And we're calling the
Yeah.
create ticket handler, right? So create ticket handler is actually a function defined inside there, so we're exporting that create ticket handler here.
Okay.
All right, so let's go back to the template file, and you can see this is like a description of what this resource is all about. And this is like us specifying a couple of policies. All right, because your function is stateless and isolated from the rest of from other things. So your function, each function in AWS has something called an execution rule, has a role attached to it. And with that role, that's how you can assign permissions to it, because they need to interact with other services. You need to assign permissions to them, just like this Lambda function would have to like create add an item to DynamoDB. So we need to add some policies to enable it to do that. All right. So we're using, if you look at the serverless or SAMS documentation, you see that there is a policy already existing that you can just attach here. All right. And you specify the table name you want to have, that CRUD ability, that is create, read, update. All right. You specify the table name, which is what we're doing. We're referencing the tickets table, and we declared or we created the tickets table down below. I know this might be strange if you've not worked with CloudFormation before, right? So all this is doing is just infrastructure automation. And next, we're also interacting with SNS, so we need to assign permission to enable our Lambda function talk to SNS. All right, and the next part of properties for a given function is the events. And here we're saying what should trigger this function. And we're saying here, this function is triggered by an API call. All right, and we're specifying the API type, which is API, which is pointing to API gateway. All right, and we're adding some properties that the paths, that is, if somebody calls the API, what path should the person call before this function gets executed? And here the path is /ticket. So if anybody makes a post request to the /ticket endpoint, this function gets executed. So this is it. This is an example of how we create a Lambda function resource using SAM. All right, the same thing is applicable to other things like the get tickets function. You can see it's almost the same thing, except that we're assigning a given number of policies, and we're also pointing to the exact method, which is get tickets. And if you look here, you see the get tickets file, and we're calling the handler declared inside this file. All right, and now we're specifying that any get request to /tickets executes this function. All right, it's the same thing we're doing for get tickets. The only difference, this one is get ticket, gets a list of tickets. This one is get ticket, gets a single ticket. Right.
Yeah.
So next, we're also doing the same thing. It's still the same thing here. Just at this time, we're saying when it comes to the /ID. So when you go to the API gateway endpoint /ticket / the ID of a particular ticket, that's when this function gets executed. The same thing is applied here, but now this one is triggered by a different event. This one is triggered by an SNS event. If you look here inside our diagram, we have a function here that the arrow points like this. So when there is an SNS publish event, this function gets executed. All right, and you can see that we're saying the type is SNS, and we're specifying the property. The property just says, this is the event, or this is the topic that this function should be triggered by. All right, so that's what this message Slack function does. And then we also have reply tickets function. This one is triggered by API gateway event, just like the other functions. And we have a resolve ticket function. This one is triggered by API gateway event as well. Then we have the tables. This is a DynamoDB table. This resource type here is just a way to simply create a table using SAM. So SAM has, a way you could just use AWS serverless simple table. This would actually create a DynamoDB table. So we have two tables here, one holding tickets, and another one holding tickets replies. Then we also have our notification topic, which is what is currently on the diagram here. That is the SNS topic. So you can see here, SNS topic, tickets created. And we're naming the topic tickets created. So anything that is subscribed to that topic gets notified once a new ticket is created. All right. So then we're also creating a new resource here, which is a dependency layer. All right. So our functions, they all make use of the same node modules. They're all making use of the same package.json. So it'd be nice for all of them to have a single dependency layer. This helps for optimization and all that. So that's what this piece is doing here. And also the next part, we're just giving an output. So whenever you run this cloud or you run SAM deploy, it would output the serverless API, and as well as the, this is generally just the API endpoint. All right, so that's a brief walkthrough of what this template file is doing. I think for those getting into SAM for the first time, this might be a little bit confusing, but once you work with it gradually, you get to understand the bits and pieces of templates in SAM, which is actually still CloudFormation template. All right, so the next part here is we're going to actually let me just first, we're going to install our dependencies, right? This is a node project, so we want to install our dependencies. So I will just open up my terminal. Okay, so I'll just run npm. I want to use a particular node version. I want to use version 18. I want to run npm I. So this would install all the required dependencies based off the packages in file. Right, so we've installed the dependencies. Now let's start creating the resources. Now these are all our functions, right? These are serverless functions, right? The create ticket function, this function creates a new issue ticket. The get ticket function, this function gets a particular ticket. The get tickets function with an S, this function gets a list of tickets, all the tickets that has been created. The message Slack function, this function is triggered by an event to SNS. And then the reply ticket function is just if you want to reply to a given ticket, like if you open an issue ticket, definitely the support team will see it and they will reply to it. Oh, look, I think you should do this to resolve this issue. And finally, we have the resolve ticket. If the customer is okay with the reply from the support team, then you want to resolve that ticket. So that's what the serverless Lambda functions are doing. Okay, so now we want to actually start deploying, create the needed resources, and then later we'll move on to implementing this function. Right now, if we open up each of the function, we see that they're just a bunch of code. They're not actually doing anything. They're just returning a response. All right. So if we go through this one, we go through to the next one, they're just returning an empty response, except the message Slack. The message Slack is actually having some implementation. We only need to add the webhook, Slack webhook URL. Okay, the reply ticket is empty. The resolve ticket is empty. So we would first of all create the resources we need. That is, create the Lambda function, even though the code is empty. Then we would create the SNS topic, create everything we need. That is everything inside this diagram. And then we start implementing each of the function. Okay, so for that, we can simply do that by, first of all, for you to follow along, you need to make sure you have AWS CLI set up and working properly. Okay, so I already have AWS CLI set up. If you want to do that, you could go through the AWS documentation and see how to set up the AWS CLI. All right, so I will just run, for you to do that, you need to just run a couple of commands. First, we do SAM build. We want to build this project. All right, so you do SAM build. Okay, so this would start using the make file to run the build. And in here, you see AWS SAM folder created here. Right, this folder is just for your local build. And after the build completes, want to run SAM deploy. Okay, so our build succeeded. So the next part is we want to now run SAM deploy, so that once we run SAM deploy, we'll create the necessary resources as defined inside the template file, and we'll go over to AWS to see these things getting created. I think that's the amazing part. So I will go over to my AWS console, and you want to go over to CloudFormation, right? CloudFormation is where you see all the template files, and with CloudFormation, you'd see that, oh, okay, they did fail, they did succeed, and all that, right? And also we'll go over to the different services that we'll be creating, and we'll see if these things were created, right? Over here, once I run the build command, you will see that a new stack is created, right? A stack, you can think of a stack as a group of resources inside one CloudFormation template file. Okay, so now we want to run SAM deploy rather. And let me just clear my terminal. SAM deploy, and we want to now SAM deploy. What next? Okay, SAM deploy. We want to do guided, right? And I want to also use a particular profile because I have multiple AWS accounts on my system. So I want to use a particular profile, which is OLabs. Right. So now once I run that,
sorry about that. Could you explain to us why you're using the guided flag?
Yeah, because the guided flag just goes through this configuration steps, asks you what's the name of the app you want to build, was several questions, right? So that it will use that to create what they call a config toml file, right? So you can think of it as it just walks you through a series of questions that makes the process easy for you, right? Especially when you don't already have a SAM config file. If you look in our project, we don't have a config file here defining which AWS region you want to deploy to, defining what's your CloudFormation stack name and all that.
All right,
so SNS is simple notification service. Okay, so stack name. What is our stack name? We want to give our stack name the same name as the application we're building. It's up to you. It's a choice to choose a name. So I'll just say ticket API. Ticket API, yeah. Okay, what region are you deploying into? I want to deploy this into North Virginia, which is US East 1. Okay, US East 1, that's already the default region. And then confirm changes before deploys. Yes, it's asking because whenever you want to make a new deployment again, there's something called change set that shows you that, look, your infrastructure, your AWS account already have this number of resources, and this number of resources will either be deleted or will be recreated, right? So we want to always confirm changes before deploy, and also allow SAM create IAM rules. IAM rules, that's identity and access management rules. These are rules required by your resources, maybe the Lambda function to talk to the SNS topic, and also the API gateway to be able to execute those functions. So I'm just going to put yes. And also disable rollback. No, I don't want to disable rollback. I think if I'm creating resources and something fails, I want it to roll back, right? Create ticket function may not have authorization defined. This okay? Yes. Yes, I'm just going to say yes to this. This is okay. Apply ticket, yes. Yes. And then save arguments to a configuration file. Why I'm going to say yes to this because I don't want to keep doing this anytime I want to make a new deployment. Let's say I update the get ticket function. I want to automatically run deploy and it deploys. I don't want to start putting in the region and all that. All right. So I just want to do this once. So that's why I'm going to say yes. Okay. Configuration file name, samconfig.toml is okay. Environment default is okay. And once you do that now, it will automatically start doing things in your AWS account, like setting up an S3 bucket to hold your source code. That is the code relating to your Lambda function. And then it will push those files to AWS. You can see that something is going out here all the way. Something is uploading, right? It's uploading a piece of code to AWS. And if we go over to CloudFormation, a new stack would be created here once this is done, right? Okay, so initiating deployment, waiting for change sets to be created. Okay, so now this is the change set I'm talking about. It tells you what is going to be added and what's going to be removed. And since we're doing this for the first time, most of the resources here are things that are going to be added to our AWS account. All right, so that's the from the notification topic, from the runtime dependency, the serverless APIs, and all that. All right, so we're just going to say yes to this. I want to do that. This would spin up, start creating our resources using CloudFormation. And let's refresh again. And you see here our
Okay.
applications Ket API is showing, and you can see create in progress. All right. This is like a description of the template, which is the same description we added right here when we were creating the template. So if you go to the template.yaml file, you'll see that we have issue tracking application, and you have that here issue tracking application. Right. So it's still creating progress. We can click through this, and you'll see the different resources that are getting created if you go on the resource tab. So you see that they're getting created, creation in progress. So we'll just hold on for a couple of seconds, and this will be done. Let's refresh. Still creating progress. Okay, so this is going to create our Lambda functions and all that. So let's go over to Lambda. Okay, just opening up the resources for Lambda so that we'll see the newly created items. So these are all the functions. All the functions has already been created here for us. So we didn't have to come here and click create function button. Automatically based on the CloudFormation template, those resources are getting created. And also, let's check our diagram here to know what are the resources that we declared. So we have an API gateway, we have the DynamoDB tables. So let's check on AWS for those. API gateway. So this is API gateway. This is where you see all the API gateway created for your account. All right, so we can see our API gateway here it's already created, and you can see the dates to show you that this happened today. And if I open this up, you see that based on the templates, these requests are being mapped to the given function. Okay, so let's go back to CloudFormation and see if the creation is complete. Okay, as we see here, the stack has completely created all our resources. That is all the things we need for application to work. The IAM role, from the IAM role to the SNS subscriptions and all that. And also, we could also go to SNS check, SNS, that simple notification system service rather. Okay, so this is SNS. We can go to topics, and we see that we have a new ticket created topic here. And if we click through to this topic, we'll see that we have a subscriber here, just one subscriber, which is our Lambda function, right? So if you if you look down here, you see message Slack function, right? So that means whenever a notification comes to this topic, it automatically gets bounced out to all subscription. And the good thing is we can actually create new subscription, and creating new subscription means if, let's say, we want to start receiving our notifications as email in our email account, we can come here and create new subscription and change the type to email. Now, when the good thing is when a new ticket is created, that message gets pushed both to Slack and both to my email or whatever email address I use. So you can see how things are decoupled, right? They are running on their own based on events, right? I don't need to update the code to do this. I don't need to start worrying about how to implement email integration to my ticketing application, right? It's so easy to do. All right, so we're done creating all the resources we need based off this template. Now let's start implementing the function. All right, so we want to hit the API endpoints, and we want this function to run and create a ticket in DynamoDB. And for that, I'm just going to be pasting a lot of code so that we can move fast. I feel like everybody watching this or is already used to JavaScript and all things JavaScript, the good word of JavaScript. All right, so I'm going to paste the first piece of code there, which is, first of all, we want to get the table, which is the ticket table, because we'll be inserting whenever a request is hit. We want to call the table and insert a new payload inside the table, create a new role inside the DynamoDB table. Next, we want to also trigger a notification, right, to SNS, right? So, and also I want to put some piece of code here to just ensure that the request is actually a post request, right? So with events, we're using TypeScript. So once you just hit dots, you'll see all the properties associated with any API gateway proxy event, right? So we're saying if the event type is post, we want to just throw an error that look, you're not. If the event type is not post, we want to throw an error to say, oh look, you're supposed to send a post request to this endpoint. All right. So next, we're now going to parse the body, right? So we're going into the body and we are going to get the events.body, and we're going to destructure the title and description, right? So I'm just going to import the iTicket type here, which is declared inside the utils type file. So if you go inside types here, you see there are a couple of two types declared here, which maps to the ticket type and the reply ticket type. Okay, so next now we create the record. Just going to paste in that. Right, so we have the new record here, which is of type iTickets, and we're saying we have an ID, we have the title of the issue, we have the description of the issue, and the date the issue was created, and we have a status here showing if the issue was resolved or not. All right, so we are just going to import UID. UID helps us just generate random IDs. All right, now we'll start running DynamoDB specific commands, which is we're going to run put command, and put command just helps us generate like query DynamoDB and add an item. All right, so we're using this package as AWS SDK lib DynamoDB. And now we've just generated a command. We need to get the client and use the client to send the command out to DynamoDB. So this is how it works with most of AWS SDKs, right? You get your client and then you use your client to actually run the command, right? So I'm just going to import the client. The client is imported from one of the files here. If you go inside utils, DynamoDB, you see we have a getDB client here. This is just using the DynamoDB client. Yep. Right, so this is all JavaScript. We've been able to send the command to add the new record inside DynamoDB on line 34. Right, next now we want to publish a notification to SNS. Right, so and that's how we do it. So we just use the publish command, almost similar to the way you do it with DynamoDB, where you have the put command, but this time we're using the publish command, and we're also getting the SNS client. Right, the SNS client is defined inside the SNS util file. Okay, so we've got the SNS client. Now we want to send the notification, right? So we want to send a notification, like, create a new notification on SNS. Right, so we have the client here. We're saying client.send pub notification, and notification just has a message inside it. We're specifying the topic ARN, and we're stringifying the record because your message must be of type string. So we're stringifying it with JSON.stringify since it's an object. All right, and we're sending that using the SNS client. Right, so next we want to just return a response which has a stringify version of the record, whatever record we added. All right, so I think that's it. This is it for the create tickets Lambda function. So we've just implemented this function. So next we need to implement the get ticket function. Okay, so I'm just going to implement like 3 of this function, and then we'll run a deployment and test the function. Okay, so I'm going to go back to the get ticket function. I'm going to be a bit quick with this one because of time. Okay, the same thing, we're trying to get the tables, both the ticket table and the ticket replies table. We're also going to be needing an ID. So this get ticket function receives an ID as a query, as a path parameter. So if you remember inside the DynamoDB template, inside the template here, we said the path was coming to get ticket was coming to /id. So inside here, we can retrieve that ID using events.pathparameter.id. Okay. So in here now, we're now getting the client as well, the DB clients, because we want to, of course, query DynamoDB to get those tickets. And also we want to get the get command, right? This is the actual command we use to query DynamoDB, right? And then we want to get this send the command. So on line 20, we're sending the command using the DynamoDB clients, and we want to throw an error if we don't find the ticket. So if we don't find the ticket, we want to say, no ticket exists with the given ID, right? And then we want to now, we've gotten the tickets, we want to get all the replies associated with that ticket. And that's what the scan command does. Okay, so we're using clients. Yeah, clients DynamoDB. Let me just verify that. Yeah, client DynamoDB. And next, we want to return a response, want to get a result rather of the scan command, right? So, and we want to map through them and format them correctly. The result formats the result correctly. Okay. So we're just mapping through, and there's a different way these items are returned. Items are shipped. So it has something like an S, like S is an object that has the type S inside it, and S points to the actual property, right? So we're just looking through and we're formatting it correctly. And next, we want to return a response which has the ticket as well as the ticket replies. Okay, so that's our response. And yeah, so we're done implementing this tickets, the get ticket function. So now let's deploy these changes. And to do that, we just need to open up our terminal again. We'll just click here, and I'm just going to run SAM deploy. Right, I'm just going to do SAM build because I want to build a project, and then run SAM deploy. So while that's deploying, we want to also start to create the thing that is going to handle the notification coming into Slack. That is the Slack bots. All right, the Slack bot. For you to create a Slack bot, you need to go to the Slack website here. This URL, I'm just going to paste it in the chat as well. So if you go to this URL here, so we're going to create a Slack application, and with that Slack application, we're going to take enable webhook, and we're going to be sending or pushing message to Slack based off that webhook. All right. So once you go to this URL, you click on create an app. You click on from scratch. You give your app a name. Let's say support ticket, and you select a workspace. All right, your workspace is definitely going to be whatever Slack workspace you want this installed in. I've already done this for CodeJam's workspace, and you click create app. Once you do that, then after creating the app, it will ask you to install the app. After you install the app, you then need to enable webhook. Okay, so I don't want to redo this again because it's just add more. So I'm just going to drag my screen over to show this. Okay, let me just see if I can drag my screen over. Okay, so this is the one I've already done. So what this you can see down here, you can see the support ticket application, right? So that's just done by clicking create app, and it automatically it will open up the the same feeling here when you click create app from scratch. You put a name, and then you select the given workspace you want this showing on. right? And then once you do that, you go up into the app interface, and then the next part is just to enable webhook. Once you enable webhook, then you want to click install app in a given channel. Then you select the channel you want the app installed. Right. So for CodeJam, we created a channel, support channel, and install the app inside there. So it's up to you the way you want it. But on enabling webhook, you get a webhook URI or URL that you'll be pushing any message you want to. So that's how it works. Okay, so I'm just going to let's confirm our change set for our function down here. We're just going to say yes. And now you see that what's the new change set is saying that it's just going to do a modification. This time it's no longer adding a new resource. It's just going to modify the existing create ticket function as well as the get ticket function, and also make some modification to the REST API. Okay, so I'm going to say yes to this. So this would start creating the CloudFormation stack. And I'm just going to open up Slack so we could see the app installed in Slack. So let me just get CodeJam Slack here. Okay, so I'm just going to remove this. And I'm just going to bring this down here. Okay, so sorry, I'm just trying to share my screen here. So this is the CodeJam Slack application where we expect, and you can see that our support ticket app is already installed here, right? Added an integration to this channel support ticket. Okay, so we're just going to now first let's ensure that our new stack has been created. Let's go over to AWS and let's look at AWS. Let's look at CloudFormation. And let's refresh this. Okay, so updates complete. That means our change has been updated. Now let's try to create a new ticket. Let's go over to and open up Postman and make a request to create a new ticket. So I'm just going to copy the API URL. Okay, so we're just going to create a ticket, but things might not work as expected because we're going to create a ticket, but we've not added the implementation for the code that does the that gets triggered, Lambda function that gets triggered. But anyways, we're just going to create a ticket and see how it feels. Okay, so let's just copy the endpoint URL here. I'm going to copy this. I'm going to open Postman. Okay, so I already have Postman here. So we're going to go to create ticket, and I'm going to replace the URL with the one I copied. Okay, so I'm going to paste that. Just going to replace. Okay, so this is the endpoint. If you look at it, like the beginning is what points to the API gateway part, and then the slash ticket is the one that executes the create ticket Lambda function. Okay, so I'd already prepared this just ahead of time so that we can be a bit fast. So I'm going to add a body here, and I'm going to say just something. Melody, what issue are you having that you would like to report?
I think that would be. Oh, my head is blank. I think I can't. I can't see my screen. I can't share my screen.
Which platform is that?
I don't know. Like I don't know.
Okay, so we're just going to type something. Unable to register a domain. Okay, so I'm just going to give a description of what issue I'm having. Um, hi, I, I, I am currently unable to register a domain. All right, so and then I'm just going to send this over send, and let's hope that this works. And we're getting internal server error, so that means something has gone wrong. All right, so this
I
is
think
good. Now
it
we're
could,
able to. Sorry.
oh, go ahead. I think it could be
Yeah, so this is good. Now we're able to go into the next part, which is trying to debug when your serverless function fails and trying to know why it failed, right? So let's go over to AWS and let me walk you through how to do that. All right, so for each function, you see in a function you have something like console.logs and all that. Those things helps you debug because every of those console.log statement is getting is actually logged on something another service on AWS called CloudWatch. All right, so when we go to a given function or when we go to a given function like the create ticket function, which is down here. You see ticket API creates tickets with some random, ID. You just click through it and you could see that this is the exact function because you can see that the trigger is actually API gateway. Right. So once you go under monitor and you see logs, all right, so the logs might take some time to show up. So the good thing to do is just click on view CloudWatch logs. This will take you over to the main service handling logs in AWS, which is CloudWatch. All right, so we have it now. You can see that this is the log that happened once we called that function. We're just going to open it and we're seeing an error. What's the error? It's saying function not implemented. All right, so function not implemented. Um, so I'm just going to go over to see why this error is happening. Function not implemented. So we're just going to go over to the code again and try to run the. Did I use a function that wasn't implemented? Put command, get command. I think everything was maybe as at the time I called it, it was still updating or something. Okay, so I'm just going to make the request again. Minimize this. Just going to make the request again. We're still getting internal server error. Let's go back to AWS and see. Oh, I see. Okay. Possibly this is happening because of the one of the function, which is the one because we're calling publish command here, and this is going to SNS, and SNS is also triggering this message Slack function. I think that's where the issue is coming from. But actually, it's supposed to work because we have some code here for the message Slack function. Just that we're missing the Slack webhook. Okay. So I'm just going to see why that's happening. Okay, function not implemented. Let's see the second error. Function not implemented. Still the same error. So I miss to run a build? Let me just confirm. So I did some build. Let's just run some build. Okay, let's look at, let's zoom in a bit. Okay, so we're seeing function not implemented as the error here on CloudWatch. So we want to find out why that's happening. So I'm just going to build it again and try to deploy it this time.
okay.
So while I'm still trying to execute this. Okay, so let's do some deploy.
Could we see the error again? Like the exact error, the
Yeah, so this is the
start.
error. So we went through the function name log and we scroll and you could see the error function not implemented, handler create ticket line 55.
Could we
Um,
check?
Now the challenge is, this thing is automatically generated and converted to JavaScript. So the line numbering might not be the same, but let's just see. Okay, line 55. Oh wow. Wow.
Yeah,
This is funny.
yeah,
Did you get what happened?
yeah. I do.
Okay,
So
I tried to
you
do
have a
automatic
UUID.
import.
Yeah, and you and you're throwing an error.
Yeah,
You're throwing
I
an
think
error.
I shot myself right in the foot. All right, so
Yeah,
I think it's good to sometimes just calm down and look
read.
at the error logs because
Yeah,
I
that's
didn't we
true.
did not actually go back to the log and look that this was line 55 and fortunately it matches the part where this issue happened. Maybe there's some kind of a map, TypeScript map, something like that.
Yeah,
Okay, so we're just going to remove this. The idea here was the idea was how I imported UID. So with this kind of import from UUID. So I did v4 as UUID, right? So that fixes the what's going on.
issue.
So what I did when I did TypeScript, command and dots, which just highlights options, and I
Yeah,
selected. I didn't know I selected implement, and it went below and did its own implementation with empty code. Anyway, that fixes that. Let's just redeploy this. So I'm just going to clear this
do
and
we need to build?
do SAM build again, and
Yeah,
then deploy.
sure.
So by the way, this is just a bash command to run a bash way of running two commands the same time. So this
Yeah,
and sign here is saying run this command after run the second command. Okay.
and it's not specific to AWS, right?
So it's not specific to AWS, it's just bash command line thing. So you can
So
as
you
well
could do,
just run
yeah,
build
you could,
and then run
you could type CD and add your and and do something else, and it's going to run it after that one. You know, it's
yeah.
just a sequential. Yeah,
Okay. So we built and we're trying to deploy an updated code with no with now an implementation rather.
yeah.
Okay,
I
our
guess
build
we
succeeded.
shot ourselves in the foot there.
Yeah, yeah. Sometimes like this, when you see errors, like you'll be like, "Wow, how did I do this? Why
I
did I
know,
make
right?
something like?"
It's crazy.
I've seen a couple of memes, and there's one meme I saw. It was a hawk. The hawk was like, why is this stuff failing?" And the little hawk just looked, and another picture showed the hawk saying, "Oh, sorry, I forgot to export."
Oh, yeah. I know, right? I think I've actually faced scenarios like this in real life where I felt like frustrated. Something was working, and I saw I wasn't, I wasn't doing some tiny thing, and it was just like crazy. It was very fun.
Yeah. So we've actually deployed our application. This would create, updates the Lambda function code. So we'll go over to Postman and we'll try to create a ticket. And fingers crossed, hope this works this time. So we're just going to submit. And yeah, so we've been able to create our ticket. This is the
Yeah.
ticket ID. This is the title. This is the description. And the result
Yep.
by default is false. And if we go over to the CloudWatch logs now and just refresh this, this might be added to a different this thing, log group. So we'll just go to the most recent log group and we'll open that. And you see that right here we have everything looks good. It's just the console info statement we did. All right, so everything looks good. And now let's look at our data inside this DynamoDB table. All right, so we'll go over to a different service, DynamoDB, and we'll open up DynamoDB. And then we'll just try to do a simple query. Right, so this is DynamoDB. We have our tables. We'll go over to our tables. You can see that one is the ticket reply and one is the ticket. Right, so we'll open up the one for tickets and we'll just click explore table so that we can see items in the table, and you see that we have one record here. Right, so I'm
Yep.
trying to open this up a bit so that it's showing. Just going to extend this, and if we click on that one record, you see that we have a couple of items. We see all the things we stored. We have the ID, we have the description, and we have the title. So that means our data is getting saved on DynamoDB. Now, the next thing, when we create a ticket, we expect that it posts a message on Slack. And if we go over to the Slack channel here, I'm just looking for the Slack channel.
I think you minimized it. You can look for it at the bottom.
Oh, did I?
Yeah, you did.
Okay, so if we go over to the Slack channel here, you see that there aren't any message, right? That's because we're yet to properly implement the message Slack handler. So that's what we're going to just do now. So we know we're done with everything relating to creating a ticket. So as I said before, I told you I walked you through steps on how to create the Slack application, and then after creating the Slack application, you connect it to your workspace and connect it and assign it to a given channel. Next, you enable webhook, and then you copy the webhook URL, and then you use that to replace this Slack webhook URL with that.
Yep.
Okay, so I'm just going to paste the one I've already done, and after this demo, we're definitely going to be deleting the Slack app. Okay, because this webhook is meant to be secret, so we're definitely going to be deleting the Slack app, but that's after the demo. All right, so this is it. The message Slack Lambda function is fully implemented now. So what the code is doing is, first of all, we're console logging so that on CloudWatch you get to see a log of every message that is coming in just for debugging purposes. We're console logging the events coming in from SNS. We're going through all the records. The event comes on as an array, and we're going through each of the records, and we're just parsing it. Parsing it means we're just converting it to JavaScript object, and then we're then trying to get an issue ID from the ID of the ticket, and we're now calling Axios and posting it through the Slack webhook. All right, so we're specifying the text here. The text is just a concatenated string of the issue ID, the message title, and the description, which is what was sent by the client who created a new ticket. All right, so that's it. And we've just created the message Slack handler, and now we need to update our deployment. Okay, so we need to run the same series of commands again. So I'll just make this easy. Sam build and Sam deploy. Okay.
Yeah.
So that's going to start the build process again, and then deploys it. Shows the new change set and asks me if I want to deploy that change set. Right. So while that's happening, let's start looking into the next piece of serverless function. That is the get ticket handler. So the get ticket handler just returns the list of all the tickets that has been created. All right, so we're just going to go through that, and I'm going to paste the relevant code. I'm going to paste that here. First of all, we want to know the table name for the ticket. We're going through the environment variables. I remember I told you that environment variable is passed from the template file here, right? So if we go back to the template file and look at the global declaration here, you see we're having environment variables, and we're passing all those variables we're using inside the function. Okay, so we're getting the ticket table name, and okay, hold on, our change set just completed. So let's just say yes to this. This is just modifying the Slack function, message Slack function. Okay, so I'll say yes to that. All right, once I do that, if we go on CloudFormation, you would notice that the stack is updating, right? So if you refresh this, you see updates in progress. All right, so we'll go back here and we'll continue with this function. I'm just trying to get my terminal back. But anyways, let me just get it back.
You use the backspace and I think control, that activates and deactivates it.
Oh, okay. I'll learn that. Okay, so we're now implementing the get ticket. So first of all, I want to get the ID. The ID is passed as a parameter. So I want to get the ID. I want to also so this is the get ticket. Sorry, I want to get a query string if the person wants the resolved ticket or the tickets that are not resolved. All right. So then we want to also query DynamoDB. So that's what this piece of code is doing. This one is just querying DynamoDB and doing a scan. Right. So we want to get the DB client. Want to also run a scan command, and right? So this is what this scan command is doing. We're querying the table which has the ticket data, and we're saying we want something where the value is directly, the name is directly equal to the value. This is saying like, okay, we want something where the resolve is true, right? Is a key value. The result value is true. And here inside the expression attributes, we're assigning the variable used for the expression here, what key it is like. So this translates into saying resolved is the key and is equal to the value, whatever it is, if it's resolved true or false, right?
Yeah.
So that's what this thing is doing. It's just all DynamoDB commands, right? So next we want to map through the tickets and we want to format it correctly. Okay, so we're just mapping through and yeah, so we're going looping through all the tickets and we're formatting it correctly based on the given shape DynamoDB returns it. So I mentioned previously that it puts it inside, let's say, description. Now description comes and description is an object that has S as a property inside, and then S points to the proper value of what description is. Okay, so that's just it. Okay, so we've got all the tickets now. We want to return a response with those tickets, right? So I'm just going to copy this and I'm going to paste it here. All right, so we're just saying we're passing the ticket array over to the ticket response, and I think that's it for the get ticket lambda function. Okay, so now let's go over to implement the reply ticket one. So I'm just going to paste that quickly. For that, I'm just going to, paste.
I think
First
we
of all,
could
once
just run.
you said,
I think we could just run through that faster because of time.
yeah, because of time, I'm just, I'm way trying to be fast here, so we don't. I'm just going to paste all the code, and I believe it's still similar to the previous codes we've been seeing, right? So, just going to paste that, and just going to paste this one. So this is us trying to get the parameters, and then we're creating a new reply, and we're trying to get the ticket ID that this reply is coming for, and we're creating a new reply. So I pray I don't make mistake with type UID again. So
Yeah, I wanted to say just that, right?
create ticket, and I'm going to copy the same thing. I'm going to go over to the reply ticket, and I'm going to paste it because it's still the same thing. All right, so we've created the reply. Now we want to add it to DynamoDB. So we just put the series of code that does that. Right, so we've added it to DynamoDB. I'm just going to import the relevant code here. And yeah, so this piece of code just creates a new put command and then adds it to DynamoDB, right? And then we want to return a response with the reply. Okay, so the new reply that was created, we want to just add it to simplify it and return that as a response. So that's it for the reply ticket method. It's just simple. I think we already provided a code, GitHub link to the code, so you can always go to the code and look at it. So next we have the final piece of Lambda function, which is this is the reply, and we have the final, which is the resolve tickets. Okay, so yeah, so this one just resolves the tickets. That is updating the resolve status on the ticket to true, right? So I'm just going to explain the code here. We're getting the ticket table. We're ensuring it's a push request. We're getting the ticket ID from the path parameter. This is passed in automatically by API gateway. All right, we're getting first of all, we want to get the tickets and this is the command that gets tickets. We also want to create an update command. That is the command that updates the ticket. Right now, it's time to run the command. We're running the get ticket command and ensuring there is a ticket before we even try to update. Right? If there is no ticket, we throw an error that no ticket exists. And then if there is a ticket, then we want to go ahead and send the command and we want to return a response and set the result value to true. Right? So that's all what this is doing. If there's an error, we want to handle the error properly and then return a 400 client error code. All right.
And
Okay, so that's
I'm believing the
said.
console logs helps us with debugging, right?
Yeah, yeah. The console log helps you debug issues, so that's why we're leaving it.
Okay.
Okay, so that's it. We've been able to create implement all the functions from all the way down. So it's been a lot of copying and pasting just because of time. Okay, so now we need to deploy this. So we run the same command, sam build. We want to build it into JavaScript, and we're running sam deploy.
Okay.
Okay, so that's going now. That's going to build, and that's going to deploy.
I think you can
Okay,
even
so
test the
go back
Slack.
to,
We already deployed
yeah, we're going
it.
to test everything. Yeah. So we're just going to test Slack now. I'm just going to create this again. And I'll go over to Slack. And I think I should see a message here. Okay, this will take some time.
It takes about a few minutes.
Yeah, I'm just going to refresh this. Okay, so it's still creating. So let's wait for it to create. So
Okay.
yes, while that's happening, let's take a look at the Slack function. Let's go over to Lambda. Let's look at the. So I can do this directly from CloudWatch. So I can go inside CloudWatch and inside log groups, I can find the one that has to do with Slack. So might be difficult. Okay, let's go over. Let's go from functions here, and let's open the one that has to do with MSG Slack. Open that. You can see the trigger is SNS, and we'll go over to monitor. I will open view the logs in CloudWatch. Okay, so we're viewing the logs now. I just want to open one of the logs and see what happened. Okay, so we're just opening this and I'm seeing this. The event came. This is the event. And next, we're pushing the message. And the message is pushed. And there was an error 404.
I think
404
that's
means not
Asus.
found, right? Yeah, that's
Oh, for yeah,
Axios
not
showing an
found.
error. So
I
why
think
is the error
something
not
is.
found?
It's an Asus call thingy.
Okay. So let me just verify the Slack. Um,
Yeah.
okay, so message Slack. Let me just verify that this URL is correct. I believe the URL is correct, so it's not supposed to be returning 404. Okay, so let's try it again since our change set's already deployed. Let's try to create a ticket again. And let's change this to, all right, so let's send this. Okay, the ticket is created. Let's refresh this. And let's check Slack.
I don't think it's a scam.
Yeah, not yet.
So I think we may have an issue with an Asus package or something of that nature. That's something we may want to look at.
Okay, that's strange because Access was actually posting it. But let's see. Let's just look at. So let's try other parts, like other part of the. Let's just look at. I'm just going to open up Slack and see. Just give me a second. Okay, so let's try other things. Let's first of all, we've been able to create a ticket that's working. Let's now let's get tickets. So I'm just going to update the URL here. I need to take the one here. Copy the one here. Going to get tickets, and I'm just going to paste it. I think there's something like prod on the front.
I think so, yeah.
Yeah. So what was it saying? Get address not found. I think I
So I
copied it
think,
wrongly.
yep, you did.
Yeah, so I'm just it's the same. Get tickets is supposed to be the same endpoint, so I was going to send that again. Okay, so these are all the tickets we've been creating. So that means the get ticket endpoint is working. So next we need to test the apply ticket endpoint. So we just take these parts, replace these parts. Okay, so just replace this part, and we'll take it from the get ticket. We'll just copy one ticket ID,
Yep.
and we'll just reply to that ticket. So I'm just going to do this. Yeah, so I'm just going to complete that, and we're just going to reply. So this is the reply I'm having. This is a message. Hi John, what kind of computer are you using? Right, so I'm just going to send this request. Yeah, so reply was successful. So let's try the get ticket endpoint to get a specific ticket. And so I'm just going to copy this and go over to the get ticket. I'm going to paste it. I'm going to remove the reply in front. This would hit the get ticket endpoint. And you can see these are all the replies for this ticket. I think we've
Yep.
tested all the endpoints. Now let's resolve these tickets, right? The resolve just changes the resolved, changes this ticket to resolved, right? So we want to
Yep.
copy that, and we want to still copy the get tickets. I think get tickets part, but this time is now we put request. So we want to paste that. We want to send that. Okay, so you can see now resolved is true, and if we go over to get ticket, we see resolved is true. Okay, so all our endpoints are working. The only thing is our Slack. The Slack. I don't know why the Slack integration is not working. I think it's because when I was doing this, I mistakenly pushed this stuff to GitHub. So somehow they this once this gets to GitHub, Git Garden will get it, and then do something to it. But just give me like a minute here. Let me just fix the issue. Just um, Um, so, what do you think so far, Melody, with the way serverless works and
I think it's really very awesome. And this shows the power of serverless computing. There are a lot of cases. I mean, this is something that if you want to integrate ourselves and start writing, a message server, a notification server and all that, it could
yeah,
take us forever. It's like reinventing the wheel, right? But with
yeah,
serverless, we have, there are cases where the main in your organization, I mean, integrating a message to Slack is not the core functionality of the organization, right? There are a lot of important
yeah,
things you need to do. So you could just use serverless
yeah,
and get that going, and that is out of the way, but you're still handling other important stuff in the organization. So it saves a lot of time, and it
yeah,
reduces that ambiguity. Like in less than about I think in less than about 2 core hours, we've been able to, I think 1 hour 30 minutes, we've been able to integrate a serverless API that connects, that sends issues to Slack, So you could do this for the same thing, like connect to, I don't know, let's say you have situations where you have your server and you have
Yeah.
your message logger or something like that. So whenever there is an issue, you could use or something
Yeah.
like which is one of the there are loggers you have. I think there's this popular one I often use. What's the name? I'm trying to remember.
Okay.
Let me see. Okay, so it just skips my brain. Uh, okay, you could use Sentry.
Okay.
I think yeah, Sentry. I love Sentry a lot. So you could use
Sentry.
Sentry and yeah, you could log a lot of events, or you could have situations where you know you could even plug this to a ChatGPT API where you have, if you have a mighty customers system coming through and you want to be
Yeah.
very friendly with your customers, so you have, you know, a lot of persons, sending criticism and all that via email or something like that, or job applications are coming through, and you just have these simple replies that are auto-generated on every fly that, okay, sorry, we'll be on you shortly. We've reviewed your message. So
Yeah.
you could just go to an admin dashboard, resolve a button, and the person is sent an email that ChatGPT composes an email and sends to the person that sorry, we've reviewed your email, but we are not sure we can move on with you, or we've accepted you, or something like that. So these are really important stuff you could do with serverless API, and I think it's really very awesome.
Yeah. So I've just updated the Slack application to include the integration, and
Okay.
we're just deploying the change set again.
Yep. Okay, so we are going to hold on to you know see the application deploy, and once that is deployed, it's fully updated. Awesome. So once Oliver is back, we are going to test that out and see how that works. Okay, I think it's just updated, so we'll test that out again.
Yes. So let's just do one more test again. We're just going to create a ticket, and that's just
And and just to prove that serverless listens to different events, you can see that the issues
yeah.
we've created, yeah, you can see that the issues we created did not get resent or stuff like that, because we're only listening to an HTTP event, which is very
Yeah.
awesome. So I think it's working now. Unable to reset a domain name. I am currently unable to reset a domain name. This is really awesome. Yeah, this is very awesome.
Yeah, so let's just try to update the message again. I don't know. Okay, I think I'm having an issue. I'm unable um, issue with OTP on
So,
SMS.
okay.
Yeah, service provider not sending SMS OTP. Right, and I cannot
And,
log into my account. So I'm just going to send this, and now you go over to Slack, you see that we're having the issue down here, issue
yep.
with OTP on SMS, service provider not providing SMS. So this is it, guys. This is our ticketing serverless application. We've gone through a whole lot, and I think that's it for me.
Awesome.
Being able to like
Awesome.
walk through all this stuff in just few minutes is
Yeah.
anyways, yeah. So that's
Yeah.
it.
So this is why you really need to subscribe to CodeJam, guys. If you're watching this video now, go ahead and smash that like button and subscribe, because we are constantly trying to bring you with real world contents that will solve real world scenarios in your, probably your organization, or help improve your software skills, right? So please subscribe to CodeJam, and trust me, like I always tell you, that we have a lot of things in the pipeline that are really very awesome and are going to keep you, going in your definitely assist your software, process and career journey. So yeah, we're hoping forward to getting there. But for the now, you
Yeah.
can subscribe, turn on your notification, and that's really awesome.
Okay, thank you guys, and I think that's it for today. So bye bye for today, and see you next
Bye
jam.
bye. Yeah, see you next jam. Take care.